Okay, so before I start, I have a question for all of you. How many of you have come across this design or drawing tools like Miro, Figma, Draw.io, and there are so many more out there? Please raise your hands. Oh, that's great. This is awesome. That means that these tools are really important. Be it a developer, a designer, a product manager, these tools play a very important role. Well, these tools are really powerful, comes with tons of functionalities, but at the same time, this can be overwhelming for a user to start with, and it does have some learning curve as well. So just give it a thought. What if there is a tool which has all the necessary functionalities, almost zero learning curve, no sign-up process at all, and a great user experience? That would be amazing. That's what we are looking for. And that's when Excalidraw, a free, open source, virtual whiteboard, which helps you to sketch hand-drawn-like diagrams, was born. And I am Aakansha Doshi, one of the core maintainers of Excalidraw. By the way, how many of you have actually heard or used Excalidraw at any point of time? Well, that's great to see. For people who have actually used it, I would really love to know your feedback, and for people who haven't, you will get to know about it today. So before I dive into how end-to-end encryption works, let's have a look how this project was started. So in 2020, during the lockdown time, when all of us were stuck at home, Viju from Meta started working on a side project. He was really inspired by this app called Swibbler, which is a drawing app, and he was building a drawing app. So he tweeted about his side project on 2nd Jan 2020 and got a great response from the community. On 3rd Jan, the repo was created, the domain name was registered, it was open sourced as well, and this side project got its name as Excalidraw. That's how Excalidraw came into the existence. And in the next 10 days, it was amazing to see that the repo got 1.5k stars and Excalidraw had 12,000 active users. And this was really great to see for a project which was started like a week back. And yes, Excalidraw has been growing since then. Well, next I would like to share how did I actually got involved into this community. So in my previous company, HackerRank, which is an interview-based platform, we were looking for a whiteboard to integrate. And after checking out dozens of whiteboards, we finalized Excalidraw due to one major reason: its simplicity. Back at that time, Excalidraw didn't really have an integration pipeline as such, which you could use to embed it into your applications. So I came up with this proposal of NPM package where people could use Excalidraw and embed it as a React component into their applications. But Excalidraw was already at a very early stage that time, and this NPM package thing would actually introduce a huge refactoring to the code base. So the team wasn't really ready for it. It took me some time to convince the team as well. But in the meantime, I really got interested in this project and started picking up some good first issues and the bug fixes, whatever I came across. And in about 4 months, the team was finally convinced. We started working on the NPM package version and we released it as well, and it's now used by a lot of applications. So that's how my journey started with Excalidraw, and eventually I got so much interested into this product that I started working on it full time. So next, let's actually see Excalidraw in action. Let's just check out the demo. So you can just go to your browser, type in Excalidraw.com, the editor just booms up, no sign-up process at all. You have all the necessary tools right in front of you to get started. So let me just draw a rectangle, and since we are at IndiaFOSS, let me just write it IndiaFOSS 2.0. And you can move this rectangle, you can even resize it, all the necessary operations which you would be looking for when you are using a drawing app. We also have image support. So let me add this image. The Super Mario, I think it's one of the most favorite childhood games. I have a lot of memory with these games. And we also have libraries. Libraries basically, so yeah, we have this amazing collection of libraries. Thanks to all the contributors who have actually helped us in making these libraries. And let me just search for something called a storytelling. Yeah, I have one here. So yeah, and I really like this one. So yeah. And since we have a website also for IndiaFOSS, so let me link it to the website as well. So yeah, now we have the website here. You can just click on the link and it will open up. So this was like a quick demo of what Excalidraw can do for you. There are a lot more things like collaboration. You can even share your drawings and a lot more stuff. So make sure to check it out if you haven't yet. Now let's go back to the slides. So we just saw what you can do with Excalidraw. Now, let's say we are building an application and I have a mock-up to share with all of you. And it has some confidential data, which I really want to be safe and secure. So what Excalidraw as an application can help me so that I as a user don't really have to worry about the data privacy, so that it can take care of the data privacy. So to help in that, Excalidraw has end-to-end encryption. And what I mean by end-to-end encryption is whenever there is an exchange of data between a sender and a receiver, nothing in between, not even the server will have access to data, which means that the data will be getting encrypted on the sender's end and will be decrypted only on the receiver's end. And this gives you the maximum privacy as well. So before we actually dive in how end-to-end encryption works in Excalidraw, let's have a look how encryption in general works in a traditional client-server architecture. So in a traditional client-server architecture, whenever there is a data exchange between a client and a server, that network, that communication is encrypted with the help of HTTPS. This is awesome, that's great. But hey, you are still storing the content on the server. So what if the server gets compromised at some point? The data could get breached too, and that would be a nightmare for us, especially for us developers, right? So we really wanted to avoid this situation in Excalidraw. So we came up with a different model that, hey, instead of sending the raw content over the network, let's first encrypt the content, then send it over the network, and let's store the encrypted content on the server as well. This way, even if your server gets compromised at any point of time, your content is still safe because it's encrypted. So this gives a lot of relief. But to work this in reality, we need to make sure that the server doesn't have access to the raw data, which means server shouldn't have access to the key with which you have encrypted the data, and which in turn means that we need to hide the encryption key from the server. Now, how do we do that? That was one of the interesting challenges to solve. But the way it was solved is really interesting. So, hash comes to the rescue. In a URL, whenever you have this hash, whatever parameters are present after the hash, they are never sent to the server, which means in this case, key equal to XYZ is never sent to the server. So why not use this behavior and store the encryption key right after the hash? That way you can actually share this URL with your friends and they can access your drawings and you are not sharing the encryption key with the server as well. So we have two things in place. We are going to store the encrypted content on the server and we are going to hide the encryption key from the server as well. So what is the next thing? Now that server is just a storage for you, server is actually not going to play any role in encryption or decryption. So how do you actually encrypt your data? It's all going to happen completely on the client, which means completely on the browser. Well, nothing to worry about that because thanks to the web crypto APIs and their great support in the majority of the browsers. So yes, we decided to use this web crypto APIs to build the end-to-end encryption model. But before we actually dive into this, how this web crypto APIs work and we dive into the implementation, there are some things which we need to understand about this web crypto APIs. So let's have a quick overview of this web crypto APIs. So we are going to use this window.crypto.subtle and it's only available in HTTPS, which means that if you are using HTTP, this crypto.subtle will be null or undefined, it will not be available, and anyways, you should not use HTTP. And this has all the generic APIs, which means that all the APIs like for encryption, decryption, signing, and all the stuff, they are not really specific to any algorithms. Rather, they take these APIs take algorithm as their objects, as the parameters, and if these APIs support those algorithms, it will work, otherwise it will not work. So all the APIs are very generic. It deals with binary data, which means that the input and the output for all these APIs will always be binary data. And the API returns promises, so we are going to use async await a lot as well. So that's a quick overview of web crypto APIs. Now, since we are going to deal with binary data, how do you actually deal with binary data? And that too directly from the browser. So in JavaScript, we have typed arrays for that. Now these typed arrays are basically array-like objects which help you to manipulate or access binary data directly from the browser. And since these typed arrays are going to deal directly with binary data, so everything we represent, all the data which we are going to represent is going to be in form of numbers only. So let's have a look, what are the typed arrays which are supported? So there are a lot of typed arrays which are supported, but we are only going to cover uint8 array. Well, Uint array is basically one of the standards and most recommended typed array, and you can pretty much represent any form of data with the help of Uint array. And U basically stands for unsigned. Int 8 is basically the 8 bits, the size of each index in this array. So we are going to use this array for all the further communication with the binary data. So let's have a look how this Uint array actually works. So let's take this binary stream of data of zeros and ones. So what happens is we divide into 8-bit segments. Now we have 8-bit segments and we convert these 8-bit segments to its equivalent decimal values, and this is what we get. And this is exactly what you see in the browser. When you are actually using this Uint arrays, this is what you exactly see in the browser. And since it's unsigned, so it takes only positive values, and since each index is 8 bits long, so it will be taking values only between 0 to 255. Now, how do we actually use this Uint arrays? So there are a few examples, like you can actually pass in the size of the array and it will initialize it with zeros. You can even pass it the numbers and it will just get it fixed with those numbers. You can even represent text with the help of text-encoder.encode API, and you can even represent emoji with the help of Uint arrays. So I think there is pretty much everything which you can represent with the help of Uint arrays. So we covered how we are going to deal with binary data. Now, there are a few more things which we need to know before we actually dive into the code implementation. So let's try to understand that. Now, what is the crypto key? Crypto key is basically an opaque representation of a cryptographical key which you will be using for encryption and decryption. So when I say opaque representation, this means that you can't view the bytes of the crypto key. The bytes will be invisible. Even if you are the developer who has generated the crypto key, you still can't view the bytes. That's how it works. And we have some properties which we can, of course, access. So let's look at that. What are the properties which we can actually access on the crypto key? So it has a type, which is basically whether it's a public key, private key, secret key, depending on the algorithm you are using. This extractable parameter, well, what this parameter does is, since by default, it doesn't allow you to view the bytes of the crypto key, but when you are actually generating the crypto key, you can actually tell that, hey, I want to extract the bytes of this crypto key later. So this parameter needs to be set to true in that case. If this parameter is set to false and you try to extract the bytes, then it's not going to work. It has the algorithm, basically the algorithm object which you have used to generate the crypto key. It has the name of the algorithm and the other specified parameters depending on the algorithm. And usage, for what purpose are you going to use this key? Is it encryption, decryption, what is the purpose? So if you specify that you are going to use it only for encryption and you try to decrypt, it will not work. So you need to specify the usage correctly. So we have now pretty much idea about what is the crypto key. We are now going to use AES-GCM mode, which is basically advanced encryption standard, and GCM is basically one of the modes in AES. It's a symmetric key algorithm, and what I mean by symmetric key is when I share the mockup with you, me and you are going to use the same key for encryption and decryption. That's what a symmetric key algorithm is. And GCM is basically one of the most recommended modes because it comes with authentication. That's why it's recommended to use it. And we are going to use a 128-bit encryption key. So what does this algorithm actually need? It needs a crypto key, which is a 128-bit crypto key, which we just discussed what is a crypto key. But in addition to that, it also needs an initialization vector, which is an IV. Now, what is this IV? Well, this IV basically adds some sort of randomness to your encryption algorithm, making it more stronger and harder to decrypt. So, which means that when you try to encrypt the same message multiple times, it will give you a different cipher text or a different result, making your encryption algorithm more harder to decrypt. So I think we covered a lot of theory, a lot of new concepts, and that is like too much to digest. So let's have I have a quick demo to show you to visualize it in a better way, because visualization always helps to grasp the things easier. So let's actually switch to the demo. So this is the demo I have, and I'm going to encrypt some text here. Let's say hello. So you can see the encryption key here because I have extracted the bytes. That's why you are able to view it. And we have the 12-byte IV, we have the encoded data, and we have the encrypted buffer as well. So now let's say let me just copy this encryption key because I want to decrypt the data. Let me copy this IV as well. And let's say I just try to remove this. Okay, decryption field, this is expected because I actually change the encryption key. Now let me decrypt it again. Okay, it worked. Awesome. So now let me actually try encrypting it again. Now if you see, the IV is changing and so is the encrypted buffer as well, but the encryption key is constant, right? This is what I was talking about when I was saying that it adds a bit of randomness, and so that your result, when you encrypt the same message multiple times, the result will change. That's why the encrypted buffer is changing. So let me now decrypt the data. It failed. Can anyone tell me why actually it failed? I have the same encryption key here, so why did it still fail? Yes, right, the IV is actually wrong here. So I need to actually use the same IV. So let's try with that same IV. Let's see if it works. Awesome, it worked. So this means that we need to make sure that when I'm sharing the mockup with you, I need to share the encryption key and the exact same IV with which I have encrypted the data. Then only you will be able to successfully decrypt the data. And that's something we need to keep in mind. Okay, so I think now it will be easier for you to visualize how it's going to work. So let's go back to the slides again. So now we are going to dive into the implementation. So the problem statement stays the same. I'm going to share a mockup with you which has some confidential data. I'm going to encrypt the mockup from my side, upload it to the server. You will be downloading the data from the server and decrypting the data on your end. So let's do that. Okay, I just skipped that one. Yeah, this one. So we have this, this is basically the element structure. It has all the properties of elements, just to keep in mind that how we represent every element in Excalidraw. So it's the JSON, that's what we need to keep in mind. So let's look at the encrypt API. So what do we need? We need an IV, we need a crypto key, and we need the data, of course, in bytes, because these crypto APIs will always deal with binary data. So now we already know about the IV, so let's just generate the IV. It's very straightforward. You just initialize a 12-bit uint8 array. It's filled with all zeros by default, and we just fill it with random values. Now if you notice, I'm using a crypto.getRandomValues API here. What it does is it actually helps in generating more secure, cryptographically more secure random values as compared to math.random, which could be brute forced easily as compared to this API. So if you are using cryptographical APIs, you should use this API for the randomization. So now we have the IV. Now what's the next thing? Crypto key. We know about the crypto key, but how do we generate it? So we have the API for that. So we will be calling this crypto.subtle.generateKey API. You pass in the algorithm object, which has the name of the algorithm, and 128-bit encryption key is what we are going to use. Of course, I need to extract the bytes later because I want to share it with you in the URL. That's why I said that is true. And I'm going to use this key for the encryption and decryption. That's the usage. So once this promise is resolved, this is what you get. As you can see, the bytes are not visible here. This is exactly what you see in the crypto key. And the type is secret because this is symmetric key algorithm. So with whomever I share this key, they'll be able to access the data. They'll be able to access my mockups. So yeah, now we have the crypto key, we have the IV. So what is the next thing which is left? Data. Data in bytes. So as I showed you earlier that we are representing every element in Excalidraw in a form of JSON. And my mockup, I will have like lots of elements. So you can imagine it will be like array of those objects, array of elements. So we need to convert those array of elements into bytes. So how do we do that? We first stringify the data. So now it's a string. And then we run, as we saw a couple of minutes back, that you can use this text encoder.encode API to convert string into bytes. And that's what we do here. So now my mockup is represented in form of bytes. We have that uint8 array. So now we have all the three things. So let's just call the encrypt API, and that's it. Now we have the encrypted buffer. So now I have the encrypted buffer of my mockup with me. So, but now what I realized just is that we saw in the demo that I need to share with you the encryption key as well as the IV. So I will be sharing you with the IV as well. I'll be opening it with the payload. So the first 12 bytes of my payload will always be the IV. You can even use the last 12 bytes, it's up to you, because the length of the IV is constant, so we can just do it accordingly. So in my case, it's the first 12 bytes. So when you actually fetch the data from the server and you need to access the original IV, you can just extract the first 12 bytes from the payload. So now I have the payload ready. So now I'll just upload it to the server. So do the API call and upload it to the server. So now the backend part is done. The data is successfully uploaded to the server. Now I still need to generate the URL with you. That I haven't done yet. And for that, I need to extract the bytes of the crypto key, right? Because the crypto key, I haven't yet extracted the bytes. So for that, we actually have a new API, export key, which basically what it does is it takes the format to which you want to export, and it takes the crypto key. So we are going to use the JWK format, which stands for JSON Web Key Format. And as soon as this API's promise is resolved, we get a JSON. And we are just extracting the K parameter from that JSON, if you see. So what this K parameter is? Well, JWK looks exactly like this. So you have all these properties, you have algorithm, you have extension, extractable, and the K. And K is basically the encryption key. That is what I need. That's why I'm just extracting the K parameter out of that response. So now I have the encryption key. Now actually I can use this encryption key right away and generate the URL. So that's what I'm doing here. I'm just creating the URL and appending a parameter JSON, which has the drawing ID, which will basically help you to download the drawing from the server with the help of this ID. And I have the encryption key. So I just append it to the hash. And this is what the URL actually looks like. So this is the URL I will be sharing with you, and I have done my job. So I am going to share this URL with you. Now when you open this URL in the browser, what's going to happen? Well, you can imagine that you have to go through reverse of all the process which I did on my end to encrypt the data, right? So let's have a look how that's going to work. So when you open the URL in the browser, you will first extract the ID and the key from the URL, because that's right in front of you. That is what you are going to do as the first step. So now you have the ID and you have the encryption key, which I have shared with you. So since you have the ID, so just get the data from the server, which I had uploaded. So you have the buffer now. You have that buffer which I had uploaded to the server. Now, since you have the buffer, let's try to decrypt the data. Let's look at the decrypt API. Now, the decrypt API looks exactly same as the encrypt API. It takes exactly same parameters. It has the original, it needs the original IV, it needs the crypto key, and the blob, the encrypted buffer of my mockup. So, if you remember, I actually appended the original IV and the blob together in my payload when I was uploading to the server, right? So why don't we get this as the first thing that's available right there? So just get it from the data. So that data is basically a buffer, and since you can't access the contents of the buffer directly, so you convert it into a uint data array, and then you extract the first 12 bytes of that buffer, which is the original IV, and then the rest of it is of course the original blob. So now you have the original IV and you have the original blob. So what is left? The crypto key is left. Well, do you actually have the crypto key? Did I share the crypto key with you? No, actually I did not share the crypto key, because what I shared were the extracted bytes of that crypto key. So you need to go back to the crypto key format, because this encrypt and decrypt APIs only work with crypto key. So what we are going to do is I just shared that K attribute with you, and what I am going to do is I'm again going to go back to the JSON Web Key format. So just adding the remaining attributes to generate the JSON Web Key format, and all the other attributes are constant, so we don't need to worry, you can just hard code it. And then there is an import key API, which is basically reverse of export key API. What it does is it takes the exported key and gives back you the crypto key. So now if you see, we have the crypto key right there, and you don't have the bytes are gone. So this is what the encryption or decryption algorithm needs, and now you can actually go ahead and decrypt the data. And once the promise is resolved, just decode the data to access the markup. Great, that's great, awesome. So we finally built the end-to-end encryption in Excalidraw. And next time, whenever you are building an application, just give it a thought whether your server really needs to access your data. If not, end-to-end encryption is the way to go. So before I wrap it up, I would just like to share how it's going on our side. So it's going great, and thanks to all the users for the continuous support and feedback. And as a result, even our company was formed on 3rd May 2021 to promote the usage of Excalidraw. And we now have a dedicated team to work and improve the editor. And a huge shout out to all the contributors who have actually helped us make Excalidraw what it is today. And I would really love to see some of your names in the list as well. So yeah, that's all from my side. If you have any questions or any feedback, let's connect. I'll be waiting right there. If you have any ideas on how we want to improve the editor, let's talk about it. So before I leave, I just want to say one last thing. You all are awesome. Thank you.